In this section, we're going to be looking at isosceles and equilateral triangles. So to start off with, we're going to look at theorem 4.3, which is isosceles triangle theorem. This theorem states if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So here in our image, you can see that if side AC is congruent to side BC, then we can say that angle A is congruent to angle B. And we would indicate this congruence with the red lines. The next theorem we're going to look at is theorem 4.4. It's called converse of the isosceles triangle theorem. So basically this is going to be the opposite of the isosceles triangle theorem. The theorem states if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So here, if angle A and B are congruent, then we can conclude that line AC is congruent to line BC. The next theorem we're going to look at is theorem 4.5. This theorem states if a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. So here in our example, we can see that line AC is congruent to line BC, and angle ACD is congruent to angle BCD. And we can see that there is a line that bisects the vertex at C. That dotted line is the line that bisects the vertex, and because it bisects at the vertex, it is also a perpendicular bisector of the base. And what that means is it splits the base in two perfect halves. So here we can see that line CD is perpendicular to line AB, and then line AD is congruent to line BD.
Next, we're going to talk about a corollary. A corollary is a theorem that can be proved easily using another theorem. Since a corollary is a theorem, you can use it as a reason in a proof. This is the corollary to theorem 4.3. If a triangle is equilateral, then the triangle is equiangular. Meaning if side XY is congruent to side YZ and it's congruent to side ZX, then angle X is congruent to angle Y, which is congruent to angle Z. You can tell this by the red lines on angle X, Y, and Z.
The next theorem we're going to look at is corollary to theorem 4.4. It states if a triangle is equiangular, then the triangle is equilateral. So if we look at this image and we see that angle X is congruent to angle Y, which is also congruent to angle Z, then we can conclude that line XY is congruent to line YZ, which is congruent to line ZX. And this would be indicated by red lines on each side. Basically, these two corollaries are the opposite of each other.